So now we're moving on to the expressions, more rational expressions, or reducing expressions. But the 1-3 section was helping us get ready for the 1-4. But the deal is, like, if I'm multiplying, I just made up something weird. If I'm multiplying rational numbers, how do I multiply them? All right, you don't even have to get common denominators for multiplying, but you do want to see if there's a factor or something that will cancel, right? So that A, before I actually do the multiplying, I try to reduce any numerator with any denominator, right? And then I just 1 times C times 4, multiply across the top. Everybody see 4C? 1 times C times 4, B times A times X. I might call it ABX, kind of do it in alphabetical order, but again, BAX would be fine. Charlie, you with us? Okay. All right. So that's the idea behind just multiplication. I need to bring out domain 2. I know for some reason domain like just throws people for a loop. Most people can give me the definition of domain. What is domain of a function? The set of all x values. That's what a domain is, right? Or we should say all possible x values, right? I had this idea in my head that maybe I did have a note sheet for this one, but I don't think I did. I'm working on getting note sheets, okay? The issue is, if I have a polynomial function, have we talked about this at all? I guess it's just because I taught it yesterday. If I just have any polynomial, do you know what the domain is? All real numbers. No restrictions, because I can take any real number, I can square it, cube it, you know, whatever. Anybody know the interval notation way to write all real numbers? To positive infinity. Interval notation. Now, I did entitle this rational expressions. What about a function that has some x's in the denominator? As I think of a domain, I think of restrictions. Are there any places where if I plugged a certain x in, that thing would be undefined? What makes a fraction undefined? The denominator is 0. the denominator is 0 when x equals -2, right? So this domain would be x such that x does not equal -2. How about the interval notation way? -infinity to -2. I usually put a union sign. I've seen even in calculus, they'll just put a comma or something. -2 to +infinity. That includes everything except for -2 and 2, because the parentheses shows that, right? But how about if I had a square root? What would make that even root undefined, or not a real number? Charlie, close your laptop. Oh, E-hall pass. Yeah, you can't have a negative under the radical. Good. So if I'm doing it that way, I'm going to probably just say the thing under the radical must be greater than or equal to 0. That's what I do, especially if it's a nice little easy thing like this. Subtract your 1, 2x greater than or equal to -1, divide by 2. So x must be x such that x is greater than or equal to -1/2. Or, what's the interval notation way? Shoot. My mouse is not even working very well. So how would I write it in the interval notation way? Bracket -1/2 to infinity. If it's included, it's a bracket. If it's not included, it's a parentheses. And we never reach infinity, that's why it's always parentheses. I think you could almost make a case to throw in a bracket there, but, you know. The acceptable math language is parentheses for infinity always. -2 is not included. It's parentheses for not included. Bracket, the -1/2 is included because it can equal -1/2. All right. Now I'm throwing in a polynomial piece and a radical piece, right? This one, can the top of this be anything? The x's be anything? Yeah, it's just a polynomial. X's can be any positive or negative number. Agreed? But we have a square root. Well, with a 4 minus x, that's right. But what's under here, we normally would just set greater than or equal to 0. But what do I have to exclude because this is a square root that's on the bottom of a fraction? I can't have 4 minus x equaling 0, right? So in this case, if it was a plain 4 minus x right here, I would say 4 minus x is greater than or equal to 0. But because it's under the fraction, I just have to say it's greater than 0. Now, how do I solve this one that has the minus with it? Plus x, that's what I usually did, and would say 4 is greater than x, or x such that x is what? Less than 4, right? Anybody tell me interval notation on that one? If you want to think of it, of the graph, it's easier to go, oh, negative infinity up to 4, not including 4. Yeah. I want you to be able to do both. If I ask for interval notation, it's the bottom. But I have noticed in recent years, like AP exam, they don't do interval notation a lot anymore. I don't know why. Like, are there other countries not doing that? I don't know. But I think interval notation can be kind of succinct. I like it. Succinct. Yeah. All right. So, domain, the majority of the problems you're going to see are just dealing with square roots, some fractions, not a lot more. All right. Then we might reach some expressions. Now I'm going back to the original one. But what if I have polynomials right here? This is just an example of simplifying. The directions might say simplify the expression. It is multiplication already, right? Any suggestions on what we need to do? Factor. Factor everything, right? What is that top left one factor as? -3, +2. This bottom one, just a little GCF of what? And then x plus 2. How about the top right? What factors out of those? Nice. X plus 1. Any suggestions on the bottom one? X minus 3. Those are almost too easy. Maybe I need to bump it up. Now, before we multiply, we definitely look, can we reduce any numerator with any denominator? Got a lot of them. All of the bottom canceled, so it's just 1. What's the only term left up in the top? Plain x. X over 1. Done.
So if it's multiplication, you can like cancel across the sum.
Any numerator with any denominator. Yep. Is that visible? 4y squared minus 9 over 2y squared plus 9y minus 18 divided by 2y squared plus 1 minus 3 y squared plus 5y plus 6. minus 6. Minus 6. This is a division though, so what should we do? Yeah, keep this one. Can we go ahead and write it in factored form since we know we want to do that anyway?
Is the last one? Is it
Minus,
five by-
minus 6, sorry. What is that top left going to factor into? 2y plus 3 and 2y minus 3, right? 2 times negative 18. I think it's 12 and 3, isn't it? Positive 12 times negative 3. Multiplies to give us negative 36, but adds to give us 9. Practicing my smiley face method if you want to. So it's like 12x, sorry, negative, positive 12x, and negative 3x. What was your question?
I was just asking.
So then, what's the highest factor of that 2y squared that goes into the 12? 2, right? 2y times what gives you 12? I said x, there were y's. 2y times positive 6. And then 2 times what gives you 2y? 2y times what gives you 2y squared? Plain y. Here, y times what gives you negative 3y? Test it. Negative 3 times positive 6 is negative 18. Are you following? Here, what are we doing? Flipping this one. So I'm going to take the factored form of that one here. Multiply to give us negative 6. Add to give us 5. It's got to be 6 and 1, doesn't it? Positive 6, negative 1. This one. Two times negative 3 is negative 6. Add, though, now to give us positive 1. Negative 2 and positive 3, yep. So, put those on our rings. Oh, I keep saying x, it's y. Highest factor of 2 that goes into 2 is 2. Guys, if you miss the highest factor, you will factor it wrong, okay? That's the one weird part. Negative 1 there. And plain y plus 3. Or factor by grouping is fine. Cancel it. Plus 6, plus 6. The heck, they all canceled? What's that answer then? 1. 1 times 1 times 1 divided by 1 times 1 times 1. Yeah.
How would you know what the first step is for the smiley face?
It's the same first step as your master product. 2 times negative 3, it was negative 6. Find the two numbers. The next step, that is the most important, is ask yourself, what's the highest factor of 2 that goes in the negative 2? It is 2. That's the kicker, finding that highest one. 2 times negative 1 gives you negative 2, right? And then 1 times positive 3 gave you 3. What would you do for addition or subtraction of rational functions? This is where we do have to get a common denominator. Oh, she hadn't flipped them. Yeah. All right, on this one, I heard common denominators. Everybody agree? That is a full term, isn't it? Add your parentheses if you need to. So what would the least common denominator be for these two? X minus 4 times x plus 6. So in the left problem, fancy form of 1 we use would be what? X plus 6 over x plus 6. Everybody agree? What form of 1 are we using for the right one? Nice. This is the fancy form of 1 y'all used. You may not have called it that, but distribute. There is a plus sign, and I already have my common denominator, right? Distribute the 3. Everybody with me? What does that top combine to? Oh, I forgot. You know, the back of the book would give you this answer of 1 and move on. But guys, what were all of the denominators that I canceled out that would have been a 0 in a denominator? Y can actually not equal 3 over 2, can it? Or what would make this denominator 0? 6. Negative 3 over 2 for that one. Positive 1 for that one, right? So I believe this is kind of an important little thing. The book doesn't even address it. I won't count off. I might give extra credit on the first quiz we take. Anything that you canceled out, you just say 2y minus 3 equals 0. When 2y equals 3, divide by 2. Yeah, it just set them off. So what would the restriction have been here? X cannot equal 3, negative 1, negative 2, or 0. Oh, because it was a plain X right here. And X equals 0, at 0. Those are just ones, But on this one, will that factor anymore? 6 times 2, 12 and 1, 3 and 4. I think we're done. And honestly, yeah, I know that X can't be negative 6 or positive 4, but on this answer, it's obvious that it can't be negative 6 or positive 4. In this answer, is it obvious that Y couldn't be any of those? No, it's not obvious. 1 is always 1. But unless Y is 3 halves or, anyway. It's just kind of semantics. So. Okay, took a little stretch break. This is a fraction within a fraction. And I'm pretty sure on that day 1 worksheet, I showed you more fancy forms of 1, didn't I? Oh, I'm so sorry. Well, so she taught it that way too? Well, now, what she may have taught is for you to get a common denominator up there, put them all together, and then leave, change, flip, or whatever. To make your work slightly more streamlined, all you're going to do is say, what would that common denominator have been? Or what is the common denominator? Times, all I do is turn that into a fancy form of 1. Big, huge, and ugly, right? And if that 1 had been some other expression, guess what I would have done? I would have just tagged on whatever that is. In fact, let's just do it. Let's just make it x. So I could just tack on an x also. What this fancy form of 1 does is it gets rid of all fractions within the fraction. Now, it's not beautiful, but I have to distribute here, right? So for the first, what term cancels out? The x minus 4 cancels with x minus 4. So I'm left with x minus 3 times x plus 1 times x. Then distribute again. I got a minus sign, right? What cancels there? The x plus 1s. So I'm left with an x plus 2 and x minus 4. The negative's still out there, yeah. Now, the beauty in the denominator is we will never distribute these out. We will never FOIL it or whatever, because it will not help us to do that in the denominator. I would say in this numerator, we got a little algebra to do. Just a little. Can you FOIL this out? You don't want to.
No.
I'm seeing minus 2x minus 3.
Yeah, what do we do with the x on the end?
Just distribute it in. X cubed. There's the first one. Minus. FOIL that out. X squared minus 4 plus 2 would be minus 2. Minus 8. Distribute that negative. I'm seeing a negative x cubed plus 2x squared. Is that what you're seeing? Minus a negative would be plus 8x. And all this was just like preliminary. All over x plus 3, x minus 4, x plus 1. Do you see how, yes, that original work looks nasty and terrible. But in the end, it's getting rid of all dealing with 2 fractions here, another fraction there, flipping and multiplying in the end, because we now are clean. Well, almost clean. Combine like terms, a bunch of canceling out. What's negative 3x plus 8x? 5x. Oh wait, did I miss an x on the bottom? Nope. Oh, it was just an x plus 3. Sorry. 8x is 5x, right? And by the way, it started out as problem 62, but when I added that x, it is no longer 62. It's my own problem.
So, if it's, oh, I just wrote something.
Now, I would say, looking at the very original problem that I made up, that can't be 0. Well, that's in the denominator. It's obvious. X plus 1 can't be 0. Also obvious. Which one? What's not really obvious? 0. I can't divide by 0 for this one. So again, my little thing, I'd probably throw in x cannot equal 0. Are you with me on that? Yeah. because there was a positive x cubed here, and when I distributed that negative sign, there was a negative x cubed. Same thing with the negative 2x squared and then a positive 2x squared. That's as ugly as it gets, I believe.
The square on the row above it was marked out, or that's supposed to be.
These two were the 3's.
Look above that.
No, the x times x was x squared, minus 2x minus 3, times another x gave us this x cubed. I just distributed here to get to this row. Yeah. Good question. Thank you for asking. Ask the questions as they come, please. As they enter your mind, ask them. Two other little things is, if I ask you, I think this was on our very first that prerequisite thing on day 1. If I ask you to rationalize the denominator, what are we going to do? Conjugate of the denominator. Just reviewing, reinforcing. Everybody got that? I'm going to suggest, in this case, because we're rationalizing the denominator, keep that numerator factored out, just in case we get some number that will cancel with the 2, right? When we distribute, we get a 9. Outer and inner will always cancel. Is that minus a 5? Root 5 times root 5 is regular 5. And 9 minus 5 is, oh, looky there, 2 reduces. So your final answer, 3 plus root 5 over 2. Yeah. And then they might say, rationalize the numerator. Yeah. Only that what conjugate will we use? Square root of 3 minus the square root of 5 over the same thing. And in this case, I'm leaving the denominator factored out, right? What would the numerator go to? 3, do you mean minus 5? Because positive times negative. Yeah. And 3 minus 5 is negative 2. And a miracle has occurred again. They reduce. Now the only one I've not gone over really is the quotient rule, but y'all just remind me, I'm going to drop those out of your homework. Pages 42 to 43. Originally it was, what was it? So 6 to 66 multiples of 3. Y'all know what multiples of 3 are? Yeah. So if we're starting with 6, it would be 6, 9, 12, 15, 18, etc., etc. Did y'all? You really did?
Yeah,
Was that like third grade or something? Fourth?
No, we just have like a Sunday thing where every set that you passed
Uh-huh.